Did you got the idea? Fourth, it help to maintain a structure and shape of plant. So an example I am telling, when water reaching in the leaf, it maintains turgor pressure in the leaf, and due to that reason leaf remain expanded. If water is not reaching up to the leaf, leaf will become wrinkled. So structural support is there, integrity is there, shape will maintain, not maintain. So for maintaining shape, water required, because water exerts turgor pressure. And if water is not there, turgor pressure will not maintain, cell become flaccid, shape of the cell will change, plant will change, getting the things. So who also have a role? Transpiration also have a role. So, and I already told earlier also, around 99% of absorbed water, already told in last class also, absorbed water loss in process of transpiration. These are the things what I wrote right now, we already discussed in the last class. Is it now? Now I am telling what next written in NCERT in this paragraph. So NCERT further wrote, a C4 plant produce twice the amount of food by photosynthesis than C3 plant. So whose photosynthesis efficiency is more? C4 plant. C4 plant perform double photosynthesis than C3 plant. And a C4 plant consume half of water than C3 plant during photosynthesis. Means who is more efficient? C4 plant is more efficient. Why it is more efficient? It is doing double productivity and absorbing, requiring half of water. Why it is happening? Answer of this question we will search in photosynthesis chapter, because for that it is important we know about C4 plant and C3 plant. But meanwhile you keep in your mind that C4 plant produce twice the amount of food, means C4 plant do double photosynthesis than C3 plant, and a C4 plant lost half of the water in compared to a which plant? Got the idea? C3 plant. Clear in the mind? Is it all right? CO2 fixation. Photosynthesis means what? CO2 fixation. So double the CO2 fixation and half the water loss. Now we are moving on next heading, that is uptake and translocation of mineral. Uptake and translocation of mineral we are going to discuss, right? So just give your attention. So I'm writing something. Most of the mineral absorbed by plant is by active process. Why? Because mineral concentration, because better to write most mineral have more concentration in plant than soil. Means most of the mineral concentration in what? Plant is more than soil. So when it is coming from soil to plant, it is coming from low to high. Because, and some mineral also absorb by facilitated diffusion. It's not like all by active transpose. Facilitated diffusion. If any mineral is more outside, then it will come by which diffusion? Simple diffusion. Why facilitated diffusion? Why facilitated diffusion? Because mineral in soil present as charged particle. Charged particle. Got the idea? So now how the uptake of mineral occur? You got the idea? Most of the mineral absorbed by which process? Most of the mineral absorbed by active process. Why? Because in plant mineral concentration is more than soil. So when mineral coming from low to high concentration, who require? ATP required. Some of the mineral may absorb by facilitated diffusion. Why facilitated diffusion? Because mineral present as a charged particle, and charged particle cannot cross through simple diffusion. Got the idea? Now I am telling you about translocation of mineral. I will draw the diagram so you will understand everything, don't worry. Translocation of mineral. Let me write first, then I will draw the diagram. So it occurs in 3 steps. First step is called loading. What is loading? From soil to xylem. And this loading ultimately by symplast. And it is mostly active. Mostly active. Second one is unloading. From where to where? From xylem to vein ending. And these unloading occur by apoplast. By apoplast, and it is passive, no energy required. Third is reloading. Reloading is from vein ending to mesophyll cell. And it is by symplast, and it is a active process. So loading active, unloading passive, reloading active. Loading ultimately by symplast, unloading apoplast, reloading by symplast. Now let me draw a diagram for better understanding of everything I wrote. You will got everything very crystal clear. Have a look. So I am drawing a diagram now. Now look, you will understand everything very easily. Now, who is the driving force for transport of water and mineral? Driving force is transpiration. If a transpiration occur from the leaf, there is deficiency of water occur in plant. And due to that deficiency, water and mineral start moving from soil to inside the plant. And water and mineral move very easily up to endodermis. By which one? Apoplastic method. So up by apoplast, water and mineral both enter into which one? Endodermis. Agree or not? Up to here any problem? You got the idea? So up to here what you are finding? Water and mineral came by which method? Apoplast. It is not crossing the which one? Cell wall. Now what happened? Casparian strips saying I will not give entry. These Casparian strips not allowing water and mineral to cross the endodermis. So they act as a check post. They are telling no entry is there. I can't allow you to go out. Now mineral, how they go into the xylem? There is only one option. And what is that option? Mineral and endodermis. How they can enter in the endodermal cell? By crossing the membrane. So mineral enter into the endodermal cell. Here it is coming. So most of the mineral present inside the cell is more in concentration than which one? Outside of the cell. So when mineral coming, here it is what? Maximum mineral is low concentration. And inside the cell, maximum mineral is high concentration, high mineral. And here you can say low concentration of mineral. So most of the mineral coming from outside to inside the endodermal cell by which process? By which process? Active process or passive process? Here mineral low, here mineral high. Mineral coming from low to high. So here active uptake of mineral occur or not? Can I write? Active uptake of mineral occur. What happened? Active uptake of mineral occur. Most of the mineral absorb actively. Then these mineral going into which one? Xylem. Then first it enter in pericycle and from here it enter into the xylem. So from soil to xylem, mineral move like this. So this is the process. When mineral moving from soil to xylem, it is called what? Loading. Loading. So is it possible for loading to occur without symplast? No, because it can enter in xylem only, it can enter in endodermal cell. So actual exchange of most of the mineral occur at which level? Endodermal cell. And it possible become of Casparian strips because Casparian strips not allowing them to move. And due to that reason, mineral get actively uptake in the endodermal cell and enter into the pericycle. So it occur by which process? Symplast. And for most of the mineral absorption, who require? ATP. And hence I wrote loading occur ultimately by symplast and it is an active process. You got the loading or not got the loading? You got the loading? Understanding came? From endodermis to xylem only by symplast. So ultimately occur by which one? Symplast. Or you can say up to endodermis it may come by apoplast, then by symplast. Understanding the idea? So it is an active process and it is ultimately occur by symplast. Got the idea? Now what is unloading? When mineral moving from xylem to vein ending of the cell in the leaf, mineral moving from xylem to vein ending, xylem of root to vein ending of the leaf, it is called unloading. So how mineral is moving up? Unloading due to transpiration pull. When water is pulling, along with water, who also pulled? Mineral also pull. And these unloading is a passive process. And these unloading occur by apoplast. Because apoplast is always passive. Why it is a passive process? Because pulling occur due to transpirative loss of water, due to suction pressure. And xylem vessels is a dead vessels. And when any transport occurs through a dead vessels, it is called what? Apoplast. So you got the unloading or not? Loading from soil to xylem, ultimately active, not possible without symplast, mostly require ATP. Got the idea? Unloading, I told, it is a passive process. It occurs by apoplast. It is due to transpiration pull. And here water and mineral moving from xylem to vein ending in the leaf. Now inside the leaf, which cell is there? Mesophyll cell is there. It is mesophyll cell, assume. And now mineral moving from where to where? Now mineral moving from these vein ending to mesophyll cell. Vein ending to mesophyll cell. Getting the idea? Mineral is moving from vein ending to inside the mesophyll cell. It is called reloading. It is called reloading. And this reloading is active. Cell membrane is involving. And this reloading is what basically? Symplast. So how the mineral moving from soil to leaf cell, you got the idea? First mineral get uptake in the endodermal cell by active process. Most of the mineral by active process. From there they enter into which one? Xylem. Later on it they transported up to vein ending. Due to which one? Transpiration pull. Now by expenditure of energy from vein ending they enter inside the cell. So this is the mechanism of transportation of which one? Mineral. I hope you understand it. So loading is mostly active, unloading is passive, reloading is active. Loading ultimately by symplast, unloading by apoplast, reloading by symplast. Is it clear? Is it all right? So done. Is it clear now? Right. Now NCERT wrote also here that these Caspary strips also help in unidirectional transport of water and mineral. Means if water and mineral cross the which one? Endodermis, it's not backflow, and it is possible due to Casparian strips. Now we are moving ahead. So NCERT also wrote a line: mineral like phosphorus, nitrogen, sulfur and magnesium are readily mobile, easily mobile from old leaf to new leaf.